Number 1, a tennis ball was dropped from the same height and at the same time that a golf ball was thrown, neglecting air resistance. Which statement is true? D. If we draw this out, we have the tennis ball here. We have the golf ball there. The golf ball is being launched out horizontally. The tennis ball is being dropped straight down. If the ground is there, then delta y is the same for both cases. And time is the square root of 2 delta y divided by ay. So if delta y is the same for both of these cases, then the time to hit the ground will be the same. That shouldn't matter, but yes. Number 2. Which arrow points in the direction of the acceleration? So that's your picture there. It is D. D as in dog. If we look at our picture here at point X, this arrow is pointing in the direction of AY, which is the only acceleration that you have. This arrow here would be the air resistance if we had it, but we don't. This arrow here, if you had acceleration in the X direction, it would be going the opposite direction, so that one's out. And then this arrow here doesn't represent anything, because again, if you had acceleration in the X direction, the arrow would be going back that way. So neither one of those work. The only acceleration that you have is the acceleration downward. Number 3, a soccer ball is thrown across the field, neglecting air resistance, which describes the horizontal components. So I think I misread this and told you guys to change it, but it's actually right like it was. So the velocity is constant, acceleration is 0 horizontally. Vertically, the acceleration would be constant. So if you want to write in here, vertical acceleration constant. A golfer drives her golf ball from the tee down the fairway in a high arcing shot. When the ball is at the highest point of its flight, C. So if the golf ball leaves a high arcing shot like that, then at the very top, the X velocity is still what it was when it started. As it goes upward, the Y velocity decreases until it gets to 0, and then on the way back down on the other side, it increases and speeds up. So at the top, the X velocity is non-zero, but the Y velocity is 0. Number 5, a ball is thrown horizontally from the top of a building with an initial velocity of 10 meters per second. At the same time, a second ball is dropped from the top of the building. The two balls have the same initial vertical velocity d. Number 6, a football was thrown with an initial velocity of 8 meters per second above the horizontal. It remained in the air for 2 seconds. Which of the following quantities was constant while the ball was in the air? That's A. The displacement for delta x is constantly increasing. The position is changing because of that. And then the velocity in the vertical is changing. Horizontally, again, it remains constant. So the only thing that's staying the same is the acceleration at negative 9.81 meters per second squared vertically. Any questions on the first page? So those are your freebies along with number 7, because they're literally the exact same questions that are on the test with the answer choices switched around to be different ones. Like the same answer choices, just switched around. Same as last time. That's made directly from the test. All the way up to 7, they're exactly the same.
What about 8 and 15?
Same problems, different numbers. Okay, number 7. Vanessa throws a tennis ball straight forward off of a building. Which graph shows the, again, pay attention to what it's asking you, horizontal velocity? Really? Because A has no velocity. That represents a velocity of 0. It's not moving. It's at rest. C is accelerating, so that C is slowing down, so it starts off with a large slope, and then that slope gets flatter. D starts off fast or slow, starts off flat, and increases. This one stays the same throughout. That's Vx is constant. Again, pay attention to what it's asking you. Horizontal velocity remains constant. Now, if it asks you what graph represents the vertical velocity, it would be neither one of these. There's not a graph up here that represents the vertical motion or the vertical velocity. To do that, you would need a graph that looks like that, where it starts off at 0 and then the slope increases, meaning that it's speeding up negatively. So this graph here, if we draw that in, that would be the vertical delta y versus t. Okay, number 8. Let's take a look at the equations first, because some of them are equations that I have never seen used ever. The first one is this dy here. You can mark that one out. The second one here, or that one there, you can mark out too, because you can't say that. You can mark out this one here as well. And then the two that are not on here, what you will need is the t is equal to negative 2 VIY over AY. So that's the time for a projectile launched at an angle that lands at the same height at which it was launched. And then the other one that you will need is the maximum height. So that's delta y is equal to VIY times t over 2 plus 1/2 AY t over 2 squared. Because the maximum height of the projectile occurs at half the time.
Is that same plus 1/2 A1?
plus 1/2 AY T over 2 squared. By the way, there is a new rule in effect for cups brought from home because people can't act right, so they're not allowed anymore. Just keep that in mind.
Like in your classroom or for the school?
For the school. That means you can't bring Yetis or sports bottles or, yeah. Anything that you bring has to be in a clear water type bottle, like a Dasani bottle or Ozarka bottle, and it's subject to search. Okay, number 8, a tennis ball rolled off the edge of a table that has a height of 1 meter. The ball took 0.35 seconds to hit the ground, 0.75 meters from the table. What was the horizontal velocity of the ball as it rolled off the table? So if we draw all of this in, that is delta y, which is negative 1 meter, because it falls below the surface of the table. It also tells you that it lands 0.75 meters away. That is delta x. And as Zane said, it tells you that the time for it to do all of that is 0.35 seconds. .35. What it wants to know is the horizontal velocity of the ball. So we go in the x direction. The horizontal Vx is dx over delta x over. So this is the way we wrote it was delta x over t. So we're going to say Vx is delta x divided by t. So Vx is going to be 0.75 meters divided by 0.35 seconds, and that gives you Vx equal to 2.1 meters per second. .35 seconds. 0.75 meters divided by 0.35 seconds gives you 2.1.
That's
0.35. I started recording it last period, and it got to the end, to the last number 15, and it cut out. So I'm going to take, when we get to 15 on this one, and splice it together with the other one. Okay. Number 9. A ball is thrown horizontally with a velocity of 18.6 meters per second at an angle of 48 degrees to the horizontal. What horizontal distance measured along the ground does the ball travel before striking the ground? So the first thing you want to do here is calculate your two velocities, Vx and Viy. So your Vx is going to be 18.6 cosine of 48. Your Viy is 18.6 sine of 48. So 18.6 cosine 48. Then move closer. So you get 12.8, 12.4 and 13.8. 12.4, 13.8. Next thing you need to know is the time, because we're going to assume that it lands at the same height that it was launched. Then we're going to say T is equal to -2 VIY over AY. The front table right here needs to stop at the side conversations. So that's going to be -2 times 13.8 divided by -9.81. So alpha y equals enter gives you the fraction bars. So that's going to be -2 parentheses 13.8 divided by -9.81. So that gives you 2.8 seconds. And then what it wants to know is what horizontal distance does it travel, so that's going to be delta x. So delta x, which is the range, is going to be 12.4 meters per second times 2.8 seconds. And we'll say that delta x is 34.7 meters.
They all use the same equation.
Huh?
They all use that same equation.
Number 10. A projectile was launched horizontally, so that one was launched at an angle. This one is launched horizontally above the ground. How long did it take the projectile to hit the ground? So we have it launched from some height, and it's going to go down to the ground like that. The equation that we have for time there is the square root of 2 delta y divided by AY. Again, the person who wrote this should be the square root of 2 delta y over AY, the way that we wrote it. I don't know where they're getting these funkified equations from that they're using here, but as far as I'm concerned, you guys know what the delta symbol means because you've seen it before in math and you can use it. Yeah. I don't know why they wouldn't use delta there, but anyway, that's beside the point. Yeah, this isn't baby science. This is big boy and big girl science. Okay, so it is falling. Oh, it doesn't matter what this number is. That doesn't affect how long it takes to hit the ground. That affects how far it goes horizontally, distance-wise. So we don't even need to use that number, and it's just going to be the square root of 2 times -2.3. It's negative because it's falling below that point, divided by -9.81. So second square root, alpha y equals enter, 2 times -2.3 divided by -9.81. You got 0.68. 0.68 seconds.
And that's the only second up.
Okay. Number 11, neglecting air resistance. If a ball is thrown 5.5 meters per second horizontally from an 84-meter cliff, I'm going to have to type this next time. how far away has the ball reached horizontally after 2.8 seconds? So this one gives you all the information. You just have to know what equation to use and what to put where. How far away has the ball reached horizontally? That's going to be range. Delta x is equal to Vx, 5.5 meters per second horizontally. So 5.5 meters per second after 2.8 seconds. So that's your time, 2.8 seconds. .5 times 2.8. 15.4 meters. Number 12, a ball is thrown with a velocity of 15 meters per second at an angle 35 degrees above the horizontal. Ignoring air resistance, what is the ball's vertical component of velocity? So again, it's just asking you for a piece of the puzzle there. It's not asking you for the whole thing. So VIY is V sine of theta. So that's going to be 15 meters per second times the sine, because we're looking for the vertical, of 35 degrees. So 15 sine of 35 is 8.60. Sine is vertical because it says vertical component. Cosine is horizontal. You do not have to put the degree symbol, no. And sine is vertical, cosine is horizontal. No, I've been recording all along. When it's black like this and just shows that part, that means it's recording. Huh? It's a student. It's the account made with the student email address. Okay. Number 13, you accidentally throw your car keys horizontally at 10 meters per second from a cliff 42 meters high. How far from the base of the cliff should you look for the keys? So on this one, you're going to have to find the time and the range. So for the time, since it's horizontal, it is the square root of 2 delta y over ay. So that's going to be the square root of 2 times negative 42, because it falls below, divided by negative 9.81. dy is always negative if it's falling below. 42. dy and delta y are the same. So you get 2.9 seconds.
Oh, it's square root.
Square root, yeah. Yeah, make sure you take the square root. And then delta x is Vx times t, so Vx is 10. So 10 meters per second times 2.9 seconds gives you 29 meters. Okay, number 14. Divers at Acapulco dive from a cliff that is 81 meters high. If the rocks below the cliff extend outward for 32 meters, what is the, it should say minimum, Horizontal velocity a diver must have to clear the rock safely. I didn't type this one. I'll type the next one. So, T is, again, it's launched horizontally. The square root of 2 delta y, which is going to be negative 81 meters, divided by negative 9.81 meters per second squared. And that gives you, I'm tired of punching stuff into the calculator, so 4.1 seconds. And then if we use our lovely math skills and we say Vx at a minimum, that means that we're going to put a greater than sign. Vx at a minimum means that you put a greater than sign. Dx over t, dx is 32 meters divided by t, which is 4.1 seconds. And at a minimum, greater than. So he or she has to be traveling faster than 7.8 meters per second, or else they bump their butt on the rocks. They bump their butt on the rocks.